how to differentiate using the first principle. So how do we differentiate by using the first principle? Now, given a function, let's say y is equal to f of s. This is y is a function of s. Let's call this our equation 1. Now the first step here, step 1, is increase y by changing y and increase s by changing s. That means wherever we see y, we write in the place of y plus changing y is equal to f of, wherever we see s, write in the place of s plus change in s. So we increase y by changing y and s by changing s. Now let's call this our equation 2. Now the second step, step 2, is subtract equation 1, which is this one, from equation 2. So you are to subtract this from this. If we do that, here we have y plus changing y, then minus y, then is equal to this minus this. So it's going to be f of s plus changing s minus f of s. You subtract equation 1 from equation 2. So it will give us this. Now, y and minus y can cancel. So that we are left with changing y is equal to f of s plus changing s and minus f of s. Now, we can call this one our equation 3. So, the next step is, step 3, is divide through equation 3 by changing s. That is, use changing s to divide through equation 3. So if we do that here, this one becomes changing y over changing s is equal to everything here, f of s plus changing s minus f of s all over changing s. We divide through equation 3 by using changing s. So this is what we get. Let's call this one our equation 4. Now the last step, step 4, is take the limit of equation 4, the limit of both sides, as changing s tends to 0. So that means it's going to be the limit of this changing y over changing s as changing s tends to 0. Now the limit of changing y over changing s as changing s tends to 0 is equal to our dy ds. The limit of this will give us dy ds. Is equal to now the limit of the other side, which is f of s plus changing s minus f of s over changing s as changing s tends to 0. So this is what we call our derived definition of dy ds. So now let's take an example. These are the steps that you just need to take when you are differentiating using the first principle. Let's take an example here. Let's say you are given y is equal to 5s and you are asked to differentiate this using the first principle. So let's just call this one our equation 1. This is the question given. Now we said the first step is increase y by changing y and s by changing s, which is this. So if you do that here, you have y plus changing y is equal to 5s, increase s by writing in this place s plus changing s. So this is what we will get. Now this one will give us y plus changing y is equal to, by using the 5 to multiply through, 5 times s, we have 5s, plus 5 times changing s, we have 5 changing s. Now let's call this one our equation 2. So we have equation 1, we have equation 2. Now we said the next step is subtract equation 1 from equation 2. So if you do that here, you have, this is our equation 2, y plus changing y minus equation 1, y is equal to this minus this. 5s plus 5 changing s, then minus 5s. And if you do that, y and minus y can cancel. Then we have 5s, we have minus 5s. These two can also go. So that we are left with change in y is equal to 5 change in s. Now let's call this our equation 3. Now the next step here, we said divide 2 equation 3 with change in s. So use change in s to divide 2. If you do that here, this will become dy over change in s is equal to 5 change in s over change in s. Now here change in s and change in s can cancel. So that this one give us, this implies that change in y over change in s is equal to 5. Now the last step, we say take the limit. Let's call this one our equation 4. So take the limit of equation 4. Now if we take the limit of this, it's going to give us lim change in y over change in s as change in s tend to 0. And we said that this will give us our dy ds is equal to the limit of the other side now, lim 5 as change in s tend to 0. Now, so our dy ds, the limit is equal to dy ds is equal to limit of 5. Now 5 is a constant, there is no ds here, so the limit of a constant is equal to a constant. In other words, the limit of a constant is that constant, so the limit of 5 is 5. Hence, if you differentiate y is equal to 5s, your result will be dy ds is equal to 5. So that is how to apply the steps